out what is hosted in the intranet, and we have the cross-site request forgery attack to do something meaningful. The attacker is actually rather powerful. So to make it more clear, so the malicious host here wants to know if there is a server at some private IP that he hasn't been able to access because of the firewall. So it sends its cross-site request forgery payload. And the cross-site request forgery payload now tries to access an image that is supposedly hosted at 10.10.10.10. Depending on, as I told you, if there's actually a server or not, a different event triggers. Usually the on-error event would trigger if there is a server, because this is really fast. If the request goes into nothing, then there's a timeout event. And this information is sent back to the attacker. Okay, but this is not a really biggie. So this is not cross-site request forgery, but it's rather important as well. So all my hosts are netted, and I use some rather obscure 10. Whatever IPs. So the IP space the attacker has to scan through is so big, I'm rather safe, people say. We don't have not only have JavaScript in our web browsers, we also have Java. And Java is something nice. Java has a socket object. And the socket object allows us to do socket connections from the website in the browser back to the host. And the socket object gives us information about the local IP. So if your company allows you to execute JavaScript, execute Java applets, then your IPs are not really that secret to the outside. Okay, what can we do, or what can the attacker do? At first he would do a ping or HTTP sweep through the intranet and see which IPs actually are hosting servers. After he found the servers, he could do a fingerprinting attack. I'm not sure here. A fingerprinting attack to load websites from the servers and try to find out what is actually hosted there. So depending on what you do there is you use unique URLs. So every single web application has a unique URL that is not shared by anyone. You have PHP Easter eggs to find out which PHP version is running on the web server. You can find out if you have Apache or IIS, because they all bring like documentation stuff that is rarely ever removed, especially in the intranet context. And you can do this really easily, especially with Firefox browsers, because you have access to the error console that gives you even more information. This is rather easy and nice to do. There are some other problems. You might encounter HTTP authentication, which pops up then, because all you're doing, or all the attacker is doing, is executed in the web browser of somebody that doesn't know what's going on. And so he wants to be stealth. And if he encounters an intranet host that is protected by HTTP authentication, nice, viewable dialog will pop up to say, give me a password or anything. But Stefan Esser, that he's here at the conference, but not in this room, I think, found a couple of nice techniques to get around this. The main technique is, okay, you send requests to the web application, but those requests are not completely valid. And therefore, the web server sees, okay, there's something, gets back an error message, but he never goes to the point where the web server itself finds out, okay, I should have demanded authentication. So this is a really nice trick. What can you do? So you can locate intranet hosts rather easily. He can fingerprint the applications, and now he has a nice list of promising points for cross-site request forgery attacks. So with home users, something that I think almost always happens is that you can change default passwords. You can use default passwords on home routers, because the home router only listens to the internal interface, and only the owner and maybe his wife and his kids have access to the interface. So why do you want to change the password? So I bet with you like 99% of all home routers have still the default passwords. Mine had before I did this investigation. And then you can, for example, change the DNS settings, put in your own DNS server and route all the victims' traffic through your internal stuff to do farming attacks or whatever. In the company context, it's interesting because you will find some unpatched servers that live in a basement and host some obscure intranet application or some old school WordPress. Why would I want to, if I use WordPress in my company to do some internal communication, why would I patch that? There's no real reason. And if you take DNS rebinding, which what I'm not talking about today, into the account, if you know what this means. Then you get full read and write access to those servers, and then things get really, really interesting for the attacker. But this is a different talk, and I'm almost finished already. Okay, there are some limitations. So the attacker has to work with timeout events, and timeout events take time. So a good technique would, for example, to have the victim to look at some videos. Videos are rather interesting, so not a cat picture, so cat video would something that I would try to host if I would attack somebody. You can try, or he can try to paralyze, so not requesting one image at a time, but like 100. Most web browsers, and especially Windows XP and Windows Vista, set limitations on the number of parallel connections that are open. So this speeds up the attack somewhat, but not totally. And also, you only can, or the attacker only can access certain ports, which is enforced by most browsers. Okay, countermeasures. This is basically 2 slides to tell you what I'm actually doing. I'm not investigating those vulnerabilities. Usually, I try to fix those, and we've built at our university 2 countermeasures. Both take effect in a web browser, so we built 2 browser extensions to protect against attacks that try to exploit applications. We built an extension that drops all implicit authentication information from cross-domain requests, which is rather unobtrusive and works. And the other one, this is Request Rodeo. The other one we built was Local Rodeo. This protects the intranet against the reconnaissance attacks. We do the segmentation between a local and remote IPs, and if a web page that came from a remote IP tries to access a local IP, the request is dropped. So it's not that hard to fix the situation, but right now we still have the problem. If you're interested in that stuff, this is my website, databasement.net, and /CSRF or cross-site request forgery. You will find links to further documents, presentations, and to the source code of our stuff. To be complete, there are also a couple of other people working on this topic. OWASP just recently started to pay a lot of attention to cross-site request forgery. They have a tool, CSRF Guard, that is J2E based and should protect the applications in a transparent measure. And the TU Vienna, so people from maybe somebody of those people is already here. They have a nice academic paper on server-side countermeasures. I haven't tried both of them, so I can't tell you if they work or no. But they definitely are nice ideas. Okay, that was it. Thank you. And the first question.
Does this mean that it's possible to maybe include a local file in an image tag that is included? Maybe the etc hosts file or something?
You could.
And then go via JavaScript over the DOM tree, pass that data.
No, you can't do that.
You can't do that.
It was possible to find out if certain files exist on the host. I think this is fixed with most browsers now, so file URLs don't trigger events anymore. But I'm not too sure about that. You should try this. It was possible a while ago, but I think it isn't possible anymore.
You can still discover which disks exist on a system.
Yeah, there's like there was numerous blog posts. Everybody tried to find out something. If you're interested, I'll give you my email address. I wrote a paper for the Springer Journal of Biology, which sums up everything that was written in this. But yeah, so it was a nice research. Somebody else?
Question to the DNS group binding.
Yes.
Does it work because the policy is port, protocol, and domain instead of IP address?
Yes, totally. So.
Will there be any changes, maybe that the switch to IP address instead of domain?
There are good reasons why you don't want to put all the your security context completely to the IP, because you have like sessions that last forever, and you have something like load balancing or other problems. And also you have situations where users can't do security decisions on IP basis at all. So all big companies have like outgoing proxy servers. So then from those, it appears that if all the applications are hosted on the same IP address. So the IP address is an address and shouldn't be used as a security feature. I think one of the things we learned in the last 20 years of security is if something wasn't designed to be a security feature, don't use it as a security feature. It will never work completely. So you have to think hard about. So cookies, using cookies for authentication tracking is like awful. You shouldn't do this.
Same as DNS.
Yeah, totally. Using DNS for the same origin policy is one of the worst mistakes ever made by web applications. And we have to get rid of the same origin policy tomorrow. If everybody, I think, agrees. Okay, so much about the preaching part of this talk. Okay, then, thank you.